Now we are in position to discuss AC in LCR circuit. Here we have series combination of resistance, inductor and capacitor as shown in the diagram, and applied voltage is represented by this signal source, and voltage across resistance is represented by V suffix R, voltage across inductor by V suffix L, and voltage across capacitor by V suffix C. Naturally, by Ohm's law, VR is IR, VL is L into di by dt, and Vc is 1 by C times Q of t. Now, Kirchhoff's voltage law will give us straight addition of these three series components, and that is equal to the signal applied. So we have VR plus VL plus VC equal to V of t, and by substituting those equations we have L into d dt of I of t plus R into I of t plus 1 by C Q of t equal to E0 sine omega t. Now here we are interested in finding I of t to make analysis of this circuit complete, and for that the unknown quantity that we want to find out is here, which is having a hidden functional dependence in Q of t and the time derivative. Now let us suppose that our differential equation possesses solution I of t equal to I0 sine omega t minus phi. And at this point of time, what we are not knowing is that this I0 and phi. So to unfold that I0 and phi, we have to substitute the derivative and integration of I of t in the first equation. So to make that substitution complete, we shall differentiate this solution I of t with respect to time, and the moment we differentiate that, it will be derivative of sine omega t minus phi will be cos omega t minus phi times omega. So Q of t will be integration I of t dt, and integration of sine of omega t minus phi will be minus cos of omega t minus phi upon omega. And here we can substitute back all these values. So the first time derivative is substituted here. The I of t value as it is being placed here, and the time derivative, which is outcome of the integration, is substituted here, equal to E0 sine omega t. So here E0 means amplitude. In earlier discussion I have considered V0, E0, they have same meaning. Now by substituting that, we have this equation. I have rewritten this equation on this slide, and now we can collect the terms together. I0 is being taken common, and omega L minus 1 upon omega C times cos of omega t minus phi plus I0 R into sine of omega t minus phi equal to E0 sine omega t. Now this equation, the last equation that we have on the screen, it must be true for all times, and I shall tackle two values of time so that I can unfold I0 and phi. Now let us tackle t equal to 0, and at that our equation becomes, if we substitute t equal to 0, omega t will be 0, and we are left with cos of minus phi here and sine of minus phi here. Cos of minus phi is cos phi. Sine of minus phi is minus sine phi. And here on right hand side, sine of 0 is 0. So here we have a simple equation that omega L minus 1 upon omega C times cos of phi is equal to r sine phi. And we can write sine phi upon cos phi equal to tan phi, that is equal to omega L minus 1 upon omega C over r. Now here we shall arbitrarily, not arbitrarily, we shall have one term in the denominator and a numerator, that is under root of r square plus omega L minus 1 over omega C whole square, and we can define phi. So phi is equal to tan inverse of this quantity, and then we have one triangle representation where this is angle phi, this side adjacent side to the phi is r, front side to the phi is omega L minus 1 upon omega C, and hypotenuse of this will be under root of one side square plus another side square. So sine of phi will deliver this kind of quantity, that is front side upon hypotenuse, and cos phi will be adjacent side upon hypotenuse, and here this phi is phase difference. Now let us rewrite that equation which was true for all times, and now this time we shall substitute omega t equal to pi by 2. So by this substitution, cos of omega t is replaced by pi by 2. This omega t is also replaced by pi by 2. This omega t is also replaced by pi by 2. Sine of pi by 2 is 1. Sine of pi by 2 minus phi is cos of phi, and cos of pi by 2 minus phi is sine phi. So here we have this equation. This equation can be rearranged for I0, and I0 is equal to E0 upon this bracket omega L minus 1 over omega C into sine of phi minus r times cos of phi. So in the earlier slide we have values of sine phi and cos phi in terms of L, C, R and omega. So those can be substituted back, and sine phi is this one, cos phi is this one, and if you substitute that, we have simplified version of I0 equal to E0 upon under root of r square plus omega L minus 1 over omega C. So here I again advise to pick up a piece of paper and pencil and make little small calculation which will easily reach you up to this equation. Here E0 upon this quantity must be the reactance of the circuit, that is total reactance of L, R, C connected in series. Now I0 is E0 upon total reactance of the circuit, and phi is equal to tan inverse of omega L minus 1 over omega C whole thing divided by R. Now if you plug in all values together, you can have a little longer equation, but complete in the sense, and this we have assumed solution where we were not knowing I0, which is in the red square, and we were not knowing phi, which is in the blue square. Now I want to plug in capital Z or even X, you can consider, that is a total reactance, and that total reactance is under root So here just we are substituting value. It is E0 upon I0, and you may prefer to write ERMS upon IRMS, and reciprocal of the reactance is conductance. It can be written as 1 upon under root of the same quantity. Now when we have a condition, a very special condition that later on I am going to call resonance condition, and we are looking for that condition where the reactance is minimum. So this reactance will be minimum when this bracket is 0, and this bracket will be 0 under the condition omega L is equal to 1 over omega C, and the minimum reactance will be simply R. Only pure resistance will take part in the reactance, and that is the static resistance of the circuit. And here this equation, this condition omega L equal to 1 over omega C, you can rearrange as omega equal to 1 upon under root LC. So this particular angular frequency, which I shall call resonance frequency, it depends upon the choice of elements. Now we shall focus a bit on phase in LCR circuit. So it is phi equal to tan inverse of omega L minus 1 over omega C, whole thing divided by R. If omega L is greater than 1 over omega C, the phase is positive and current lags behind. Why lags behind? Because phi is positive and it is with a minus sign we have considered at the initial point. So the phase of the current is lagging by angle phi in case omega L is greater than omega C. The second option is omega L less than 1 over omega C. Then the phase is positive and current leads. So here this value phi will be minus, and minus minus it will be plus, and the current will be ahead of voltage by that particular angle phi. Then if omega L is equal to 1 over omega C, there will not be any phase difference. The current in the circuit will be in phase with voltage. Now here you can see this slide where we try to show up that phi is positive, phi is 0, and phi is less than 0, that is negative. So here omega L is greater than 1 over omega C, and here the height of this arrow above x-axis is more than below x-axis. So here it is equal and here it goes unequal. Now these are wonderful diagrams which can tell you how phase in the circuit rolls. So here the phase of 60 degree between current and this voltage is being showed up here in the sinusoidal plot. Here once again we try to show up maximum amplitude as 1. RMS of maximum 1 is 0.707 times the maximum value, and average is 0.636, obviously for half cycle, and for complete cycle it is 0. We have already discussed this. Now here you can go through the different angles. The beginners I would recommend them to look at this diagram, pause this video and finally look at this diagram. Now for pure resistive circuit, we have current in phase with voltage. So here both the arrows are shown in the same direction, and as time rolls they will rotate in anti-clockwise way, the way they are plotted here. For pure inductance, current is lagging behind, and this combination as whole will rotate about the origin, and in capacitance current is ahead by pi by 2.